Hello everyone, I'm Leena Arutya. Today I'm going to present you about data visualization and its techniques. First, mainly we will look into the outcomes of this section. Firstly, we will look into what is meant by data visualization and the importance of data visualization and how do you start visualizing the data and why data should be visualized, types of data visualization stats and fundamental design principles of data visualization. The first one is what is meant by data visualization. It is a graphical representation of information and data. What is meant by data visualization? It is nothing but a just graphical representation of data and the information by using visual elements like bar graphs, charts, maps, graphs, etc. Data visualization tool provides an accessible way to see and understand trends, patterns in data and outliers. The tools of data visualization helps to provide easy way to understand patterns in data and outliers. And we'll look what is the importance of data visualization. This is important because it allows trends and patterns to be more easily seen. With the rise of big data upon, we need to be able to interrupt increasingly larger batches of data. Machine learning makes it easier to conduct analysis such as predictive analysis, which can serve as helpful visualization to present. Why data visualization is important? Because it allows trends and patterns to be seen easily. With the help of big data, such as a large bulk of data, with the help of machine learning, it is it it will make easier to conduct analysis such as which type of analysis, predictive analysis, which helps the user to visualize easily. And why data to be visualized? See, let us look into it. We need data visualization because a visual summary of information makes it easier to identify patterns and trends than looking through thousands of rows on a spreadsheet. It's the way the human brain works. Since the purpose of data analysis is to gain insights, data is much more valuable when it is visualized. Even if a data analyst can pull insights from the data without visualization, it will be more difficult to communicate the meaning without visualization. Charts and graphs make communicating data findings easier even if you can identify the patterns without them. Why? What is the purpose of data to be visualized? See, it makes us to be more easier to identify the patterns and trends. Such as if you are looking into the spreadsheet, there are thousands of rows and columns, right? It is the way our human brain works. By visualizing the data, it is much easier to us to gain the insights of what we are looking. Without data visualization also it is possible, but it is much more difficult to analyze the data and to communicate what we want. See, we'll look how you start visualizing the data. How we'll start visualizing the data? First, we need to have a basic understanding of data and present it without misleading the data. Firstly, we need to have a required data enough with us without having any wrong information or any errors in the data what we are having. And the basic step for data visualization is what? Exploration and explanation. These are the basic step of the data visualization. How data visualization is done? Basically by represented by chart, bar graphs, maps, dashboards. All these are the representation of data visualization. uh, and the next one is types of data visualization charts. Types of visualization. The first one is we have different types of visualization charts like line chart, area chart, bar chart, histogram, and pie chart, scatter plot. And all these are the types of data visualization charts, and there are many more, but we'll look at a few of them. Line chart. A line chart illustrates changes over them. The x-axis is usually a period of time, while the y-axis is a quantity. For example, a company sales for the year broken down by month, or how many units a factory produced each day for the past week. See, line chart is nothing but we have the x-axis and the y-axis. X-axis is usually for the period of time, and the y-axis is for a quantity, right? Here is the better example that we can understand the line chart more easily and thoroughly. Suppose if we take a company and we'll take the company sales broken down by month and how many units factory produced. Month is represented in the x-axis, and how many units means quantity. Quantity produced by the factory is represented in the y-axis. Area chart. The second one is area chart. An area chart is an adaptation of a line chart where the area under the line is filled in to emphasize its significance. The color fill of the area under each line should be somewhat transparent so that overlapping areas can be discerned. We are much aware of the area chart, right? And the third one is bar chart. We are much aware of this bar chart also, right? From since we are from childhood, we saw we used to draw bar chart and all those, right? Line chart, all those. Bar chart. A bar chart also illustrates changes over time. But if there is more than one variable, a bar chart can make it easier to compare the data for each variable at each moment in time. Yes, if there are more than one, then bar chart will comes into the picture. For example, a bar chart could compare the company's sales from this year to the last year. The next one is histogram. A histogram looks like a bar chart. A histogram is similar to the bar chart, but what is the difference of the histogram and bar chart? In histogram, it measures the frequency rather than the tense over the time. Here, bar chart, here we will measure the time over the time period, and in the histogram, we will measure the frequency rather than the time. The x-axis of a histogram lists the bins or intervals of the variable, right? See, one interval, second interval will be represented in the x-axis, and the y-axis is frequency. So each bar represents the frequency of that bin. For example, you could measure the frequency of each answer to a survey question. The bins would be the answer: unsatisfactory, neutral, and satisfactory. This would tell how many people gave each answer. And the next one is pie chart. We are much aware of this pie chart also. A pie chart is the best option for illustrating percentages because it shows each element as a part of whole. So if your data explains a breakdown in percentages, a pie chart will clearly present the pieces in the proper proportions, right? A pie chart is represented for making use of the percentages. When our percentages are to be measured or calculated, a pie chart is the best one that suits it. Scatter plot chart. It also called as scatter chart or scatter graph. Dots are used to denote values for two different numeric values. And then next topic is fundamental design principles of data visualization. There are 9 fundamental principles. The first one is balance, emphasis, movement, pattern, repetition, proportion, rhythm, variety, and unit. Firstly, we'll look into the first most one is balance. A design is balanced when the key visual elements, color, shape, texture, and negative space are equally distributed across the frame. Means when it is balanced, when the texture or shape or color is equally distributed all over the frame or in the dashboard. This doesn't mean each side of the design in an exact replica of other. Necessarily, you can achieve asymmetrically balance by offsetting larger charts and graphs with the small elements. The second one is emphasis. Emphasize important data by drawing the user attraction to using color, size, negative space, or contrast. The goal of the principal design of emphasis is to ensure that users see the most important data first. In Western culture, people read from left to right, starting at the top of the page, which means you can emphasize certain data points by placing them where you know users will naturally look first. The top left corner. Emphasis is nothing but ordering or ordering the data, or giving importance to the first step. The third one is movement. Much like emphasis, the movement principle draws the viewer's attention in a certain direction. Ideally, your design should mimic the way people read in an F pattern, starting at the top of the page, moving across it, and then down. You can also create movement across your dashboard by using complementary colors to pull the user's gaze across the page. So, this concept of movement is ironically typically applied to static images. A dashboard software that employs animation and interactive intelligence serves this principle nicely. Movement is nothing but used for animation, graphical visualization is used in such type of areas. Pattern. The fourth one is pattern. It's pretty simple concept. Repeated objects create a pattern. Yes, right? Repeated object will create a pattern. When it comes to designing a dashboard, patterns are ideal for displaying similar set of information or multiple set of data that equal in value. If you have the several set of similar data and want to avoid emphasizing one over the other, establish a pattern by using similar object colors, charts, types of to display the information. If similar type of data is there, then you can represent it by using same colors or same type of charts, etc. The fifth one is repetition. Artists use repetition to make their work look active. While you don't want to overheal users by making your dashboard appear too busy, you can communicate relationship between the sets of data by representing types, shapes, colors. Repetition tells the user, hey, these two things have something in common. Repetition is nothing but two things are having same pattern or something, are looking same or similar to each other. Proportion. In pie chart, in a piece of art, proportion involves the size of each object. If you're drawing a person next to a house, the house is going to be bigger. Well, that's the way houses are. In the sense of data visualization principle, proportion is twofold. It can indicate the importance of data sets along with the actual relationship between numbers. If you want to emphasize the importance of specific data set, make it bigger. Additionally, make sure each chart accurately reflects the relation between the numbers in it. If a slice of pie chart is labeled 45%, it should actually take up 45% of the graph. Proportion is nothing but ratio and proportion, right? Similar here. Rhythm which is closely related to the movement. Generally speaking, a design has a proper rhythm when the design elements create movement that is pleasing to the eye. If the colors, shapes, or characteristics of the dashboard create a sense of visual sharpness, consider rearranging them so that user eyes moves across the data smoothly. Rhythm is nothing but a voice or a tune which have a similar, right? In music, we all are aware of this rhythm, right? Similarly, variety in color, shape, chart type is what keeps user interest and engaged with your data. If your dashboard is boring, chances are need a little variety, yes, or to look your different or data visualization different, then you need to add some extra content like object shapes, which will be different from all other data visualization techniques, right? And the last one is unity. Much like balance, unity ensures that every part of your design is concrete. This gives your dashboard the impression of having an overarching theme, and it will happen naturally if you have already implemented the other other core principles of data visualization. If your dashboard doesn't feel unified, revisit the other 8 design principles and make sure you're employing them. Right, unity is similar to balance, right? If you don't feel much unified, then you can revisit the 8 principle and make the necessary changes, and you can make them as unity, right? That's it, guys. This is about data visualization techniques and fundamental designs of data visualization techniques. We have discussed what is meant by data visualization, why data to be visualized, how data is visualized, and fundamental principles of the data visualization techniques. Thank you, guys. That's it.